Identity number 12 will work on the left side. So let's first switch everything into sine and cosine. So this tangent here has got to get switched. So we're going to have the sine of alpha over the cosine of alpha plus cosine alpha over 1 plus sine alpha. Then what we're going to do is get a common denominator. So guys, when you're working with these problems, what I'd recommend doing is once you switch everything to sine and cosine, when you have fractions, the next step is to go ahead and put those fractions together. So this guy over here on the left side is missing a 1 plus sine alpha. And this guy on the right side is missing a cosine alpha on the bottom. So that'll be, I'll write it like this for you. So what I've done is I've multiplied by 1 over here and 1 over here, so I haven't changed anything. So this is going to give us, when I distribute this in, this will give me sine alpha plus sine squared alpha. That's when I distribute this sine into both these guys. Plus cosine squared of alpha. That's these two guys multiplied together. And now they're over our denominator. And I'm not going to multiply these two together yet. So one of my rules is don't multiply the denominator together until you last need to, because odds are at some point you'll have to refactor things back out. So what do we have? Well, sine squared and cosine squared is 1. So these two guys right here, that thing's equal to 1. So what I have on the top is sine alpha, this first piece right here, plus 1, okay, over cosine alpha times 1 plus sine alpha, like that. Now here, the numerator, this piece, and the denominator cancel out because they're the same. So that's going to give me 1 over the cosine of alpha, which we know is the same as the secant of alpha. And that's what we're trying to prove.